Fluid flow. Well, fluid flow, I already have some things. So water flows from a bigger pipe to a smaller pipe. And the flow rate will stay the same, but the flow speed will be different. Hence, I put this here. Flow rate is different than the flow speed. Right? You're going to have some V1 here, and then you're going to have some V2 here, and the two speeds will not be the same, but the flow rate will be the same. So what do we mean by the flow rate? It's kind of obvious what we mean by the flow speed. I think that things are flowing. Now, flow rate, that's going to be the volume of water per second. How much of the actual water is flowing every second through the pipe. And it should be obvious that the flow rate in this pipe should be the same as the flow rate in this pipe. That is, if every second you can push 10 molecules into this pipe, then every second 10 molecules will come out of this pipe. Yes, that would be conservation of mass. So the flow rate stays the same. The flow rate here is the same as the flow rate there. So I'm gonna put here like flow. I don't really have a symbol for it. Flow rate. One, yeah, that doesn't really look good at all. Whatever. Flow rate here is the same as the flow rate there. Now, flow rate is the volume over per time. Volume per second. I'm going to put here per time is better. Volume per time. So what I can do is I can take a section here, a circular piece, and then here's my volume. So I can take this volume. So let's say volume 1. If every second I can push this volume of water through, then the same volume here must also flow through this, but obviously it would be distributed a little differently. How do I do that? I do it this way. Anyways, and this volume here, volume 2, these two must be the same. Every second I can push the same volume through both of the pipes. So volume 1 per time or per second equals volume 2 per second. I don't know, per 3 seconds. Per time it's really what I should have here. Let me change this out. Per time. So the flow rate is the same in both pipes. Now, these two are the same, so I'm just going to get rid of that. And then the other piece is that here's delta x, 1, the distance through which the water molecule will travel, and in a certain time, delta t. And then here's delta x, 2, and the particle will travel that distance in the same time, delta t. So volume itself is going to be that area times this displacement here. So I'm going to have area times, this is A1, area times delta x1 over time. T, I'm going to put delta t here, equals area A2. This is my area A2, that little piece here, A2 times this displacement, delta x2, that's the volume divided by the time. And now I have what I wanted. So first thing to note is that this stays the same, but the second thing to note is that this is just speed V1 and this is speed V2. And so what I have is A1 V1 equals A2 V2. Now flow rate, there are two equations for it. So flow rate is either volume per time or area times the speed. What you need is this equation and this equation. Let me solve problem 1 off of this one. So number 1, this may just be worksheet 2. It looks like this. Worksheet 2. I'm going to solve problem 1. So flow rate in the pipe is flow rate. I'm going to put here like volume per time is equal to 0.2. Wait, wrong. Oh no, okay, it's equal to 150 meters cubed per second. So 150 cubic meters every second is how much water is flowing through the pipe. I have the area of the pipe. I guess we will need that. 0.2 meters squared. And the question is, how fast is the water flowing in this pipe? So I'm looking for speed. Well, flow rate is A times V. Now I know this is 150. I know this is 0.2, and there's my V. So this is 75 times 10. 750 meters per second is the speed. That's fast. That's fast. Yeah, apparently that's it. Okay, so here's a problem one, and then once you're done with this one, you can solve numbers 2 to 6, and then don't worry about 7, 8, 9, or 10. If I'm not back in time to do 7, 8, 9, or 10 with you, then we will just have to skip that. But you do want this stuff. This may show up in your exam, so you do want to make sure that you know what's going on here. Okay. Well, this will do for fluids.